Now, if you think about it, the Earth is basically a great big capacitor. The ground carries a negative charge, then there's the insulator, which is the air, and the top layer carries basically a positive charge. And between the two is an electrical field, and it's been measured around about 100 volts per metre. And it's thought that it affects the biology of life on Earth. The trees are thought to make use of it, as are plants, and bees are thought to use that field to find their way to flowering plants. Of course, the existence of it is perhaps most readily recognised in things like thunder and lightning. On average, a storm is thought to contain about 10 million kilowatt hours, and that's about the same as a 20 kiloton nuclear warhead. And of course, some storms are 10, maybe 100 times more powerful. That's a lot of energy. In essence, that electrical field is thought to be generated by the bombardment of cosmic rays on the Earth and the Earth's natural radioactive decay. So given all of that mysterious power that's just hanging around in the atmosphere, is it any wonder that people have been fascinated by it? I mean, fascinated before June 1752, when Franklin did his famous kite experiment, people were working on trying to understand what this was and trying to work out how it might be harnessed. Today there are basically two ways to do this. The first is what's called an electret motor. It was first envisaged by a chap called Oleg Jefimenko, and he put an electret in what he called the open slot arrangement with two plates above and below it, one attached to an antenna and the other attached to the ground, and sure enough it turned. Now, an electret is the electrostatic equivalent of a magnet. You can make one, you basically get some wax, melt it, stick it in a very strong electrostatic field, and we're talking kilovolts, let it set, and you will have yourself an electret. Early electrets were made into something called an electrophorus, and you can equally make one of those if you like. But the second type, which I consider an easier type to make, is the corona type. Corona motors have been known about for centuries, and they work because air will ionize. If you have two highly charged plates, and we're talking about kilovolts here, the air in between them will be stripped of their electrons and create positive ions. Of course, once those positive ions are created, they'll be repelled from the positive surface and attracted to the negative surface, causing a flow, and that is corona discharge. If you arrange that so the flow is towards a drum, and there are spikes pointing at the drum, then there'll be enough corona discharge to actually spin that drum. Now, the issue with these has been that there's not a lot of power, and they're the basis of the corona motors made by people like the Plasma Channel, for example, and Lidmotor's Atmo motor. The genius of the Atmo motor from Lidmotor is that he runs this from that potential difference in the atmosphere that we were talking about, and he's created a motor that's powerful enough to be a drill. Now, they're really easy to make. All you really need is accuracy and some of this stuff. This is aluminium foil for heating and ventilation, and of course we have a 3D printer for accuracy. So I drew up and printed these things. What we have here are two side plates, 16 of these blades here, a drum right there, and 4 support pillars. Now, there is some argument whether this runs because of that corona wind or ion wind we talked about, or because repulsion and attraction between the negative and the positive, because half of these get attached to Earth and half of them get attached to an antenna. But people do like to argue, and maybe it's one, maybe it's the other. The other thing I've got is this stuff, which is 150mm long aluminium tape, and our first job is to cover the blades with the tape. So they end up wrapped like that. Now, I wrapped it that way around, so this is the jagged end. Once we've done that, we need some black electrician's tape, and if you look carefully, 1 centimetre from the end, you'll see a tiny bump. And you want to wrap around 3 or 4 wraps of electrician's tape on one end only. So they're like that. Now, you're going to need 16 pieces of multi-stranded wire, preferably black and red, but it doesn't really matter if you haven't got black and red. What you do is take off about the last 1.5 centimetres, and it needs to be a multi-strand because you spread out the braid, put a bit of glue in there, and then press that into that channel so it's level with the channel and wait for the super glue to turn. Once it's done that, that's what you get. And now we need to wrap this half in the same way that we wrapped that half, because this is a contact connection. It's going to be fine for the high voltage that we're using, but we don't have to solder. We just have to make sure that that wire is in contact with the aluminium, and we press it down with the tape by wrapping this end. And you do 8 in red, 8 in black. Okay, so you should have 16 blades, in my case 8 with the red and 8 with the black. Now at this stage you should test continuity, because this is a press fitting, usually pretty good, but we need to test it to make sure we've got continuity, because it's easy to change that now. Once you put things together a bit more, that'll get a bit more difficult. So I've got a meter there and it's measuring ohms, and for continuity I want a very low resistance, a low ohm reading. So if I measure the resistance on the end of the wire to the plate, it's about 0.4 of an ohm. Okay, so I've got my base plate and I put a stator bearing in there, 22mm by 7mm by 8mm, and in those round holes these pegs go, because they're the support bearings, and 4 of them, and then in these teardrop, hairdrop shapes we put our blades, and the blades go so that one half faces with the wire towards you, and the other half we feed the wire in and face the wire toward me. Right, when that's done and it looks like that, we need to put the top on it, and the top is this one with a great big hole in the middle. Line that up and fit all those little pieces in their slots. Right, that's it all together, and I've tidied up the cables basically by just gluing them around. And remember, that is going to be the ground and that is going to be the antenna. What we need to do now is take this, the drum, and we need to cover it in this stuff, which is our aluminium foil. And the drum and foil are 100mm across, so we just roll some of that off, stick it on, and that's the drum finished. So I've coated it, and I've also terminated these wires with lugs. Now this one slides in with the short axle facing to the back, so you slide that in place, engage it, and then we have this. And there's a slight conical cross section to this. It's got a bearing in it, of course, that goes with the bearing facing there. The conical cross section means that it's kind of self-seating, so you just press that into place, and there we go. That is our Corona motor finished. All we've got to do now is see if it works. Right, to get this thing running from atmospheric energy is probably not going to be possible for me, because I don't have a drone and I need to fly a wire quite high to be able to do that. And if you watch Laser Saber, you'll see he in fact takes this model and does exactly that. So I'm pretty sure that if this thing works, we'll be able to work it from atmospheric energy. But what I have done is I've got this wire and it goes to a clean earth. So I've sunk an earth rod in the ground outside. This wire goes through the window, and it's a separate earth from the house earth, so it's what's called a clean earth. And the clean earth goes on to the negative like that. So this needs a high voltage input, a static energy input, and we could do it with a whole range of different things, including polishing a piece of PVC pipe with some wool or paper. But I have this thing. It's a Van de Graaff generator up to 500,000 volts that I built when I first started doing the channel, and it's been in the garage for absolutely ages, so I dug it out, I've put it in a different room, and I'm going to run a needle aerial to it, which is here, and it's quite literally just a needle on a big lump of plastic, and we'll connect the other side of that here and that side here. Then I'll scurry off, turn on the Van de Graaff generator, and we'll basically see what happens. I might have to put this a little higher maybe, but something like that. Okay, that's actually working. I better go turn the generator off and discharge it. Okay, so it didn't have a lot of torque. I was able to stop that just by resting my finger on it. But certainly Lasersaber is doing some wonderful things with this basic design. I mean, it is his design, okay? I just copied it. So I would jump over to his channel and be really fascinated by this kind of thing. I think my next project, well, another project, is going to be an electric version of this, which is much more like a standard motor. But atmospheric motors and ways of using atmospheric energy are certainly an item of very active research if you want to look into it. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.